finding distance between 2 points, the point line distance formula. And it's something that you may have remembered studying in geometry. And if not, though, that's okay. That's why we want to go through it. You certainly obviously follow along or see if you remember and then can check your notes. But the point line distance formula that helps us measure distance can be given by the following. So distance equals the absolute value of ax plus by plus c all over the square root of a squared plus b squared. Now, what do these letters stand for? So if you have some point x comma y, and you're trying to measure it to some line, and we know that we measure distance perpendicularly. So that would be your distance that you're trying to figure out. The equation of the line has to be in general linear form. And what that means is that it has to be set equal to 0. So make sure that you're in general linear form. And then now you can see exactly where the a, b, and c come from. There's your coefficients a, b, c. So those go in the top of the absolute value. And then your point x comma y also goes there as well. So you have to know this formula, the distance formula between a point and a line. And so I just wanted to go through a couple of examples. So the first example says, here's our point, and notice our line is not in general linear form. No worries, we can easily fix that. So the first thing I might want to do is write this line as 2x minus 10y minus 4 equals 0. Okay, fantastic. So we have our a is going to be 2, our b is going to be negative 10, our c is negative 4, and we know the point here 4 comma negative 7. So I'm going to go ahead, and pick that color, sorry. Write my distance formula one more time, just so I can remember that a. Absolutely have ax plus by plus c, all divided by the square root of a squared plus b squared. Okay, so, make sure you are careful of your parentheses, or in this case, absolute value. So 2 times 4, 8 times x, plus negative 10 times negative 7, and then plus c, so plus negative 4, all divided by the square root of a squared, so 2 squared, which is 4, plus negative 10 squared, which is 100. So let's simplify that. So our absolute value, we get 8 plus 70 minus 4, all divided by the square root of 104. Okay, so we get 74 in the numerator, it's already positive. And we get the square root of 104, which is 4 times 26. So that's 2 root 26. We can certainly simplify that, divide by 2 at least. So we can get 37 divided by the square root of 26. If you want to leave it like that, go ahead and rationalize that to 37 root 26 over 26. And that's our distance. So that would be this perpendicular line that measures a point to that given line in general linear form. Okay, so now that formula can certainly be used to find the distance between two parallel lines. We just have to interpret, okay, how would we apply that? Well, two parallel lines, the distance is constant. So you just have to figure out in one of your lines, pick which point, any point you want, but pick a point as your xy, find that point, and then the other line becomes the one that's in general linear form. So these are the two lines that they give us. It doesn't look like they're parallels simply because we don't have them in the same format, but they are. But if you want to just double check, you could certainly simplify that first equation. I think I'd clear it by multiplying by a 4. So I could see, that's 2x equals 3y minus 44. And if we put that in general linear form just to see, negative 2x plus 3y minus 44 equals 0. And certainly if you put the other one in this general linear form, if you move everything to the left, you would see that you'd get negative 2x plus 3y minus 1 is equal to 0. So I can tell that those are parallel lines, even though it's not slope-intercept form. Sorry about that. But if you take a look, your ratio of x's and y's are the same when they're on the same side of the equation. Okay, now, hint, maybe, or suggestion. So it might be easier to use the second one, the one I just found, as my line. Maybe use this one as my line, and then maybe try to identify a point that's on this particular, um, find a point on that line for your x comma y. So right away, the thing that pops up in my head is negative 22 comma 0. That one would certainly lie on that line, so I'm going to use that as my x comma y. I like that there's a 0, and that I have to use 22, but it's better than using 44, I guess. I don't know. And then over here becomes my a, my b, and my c. So again, I'll write the formula just so I can see it, visualize that, practice writing that. Absolute value of ax plus by plus c divided by the square root of a squared plus b squared. Okay, so our a value, again, our a, our b, and our c will be generated from the line. So my distance is the absolute value of negative 2 times x, which is negative 22, plus 3 times 0, so that's very nice, plus negative 1, all divided by the square root of a squared, so 4 plus b squared, 9. So our numerator, we just get 22 times 2, so 44 minus 1, so 43. And it's already positive, divided by the square root of 13. And again, we could leave it like that. We could rationalize. Doesn't get us a whole lot since both are prime. 43 root 13 over 13. Okay, so, and much like what we saw the other day, the point line distance formula can extend to the third dimension. You just extend each of your fractional pieces one more dimension. So your point now is an x, a y, and a z, and your line in general linear equation, your plane in general linear equation is an a b, a c, and then also a d. So when we get our formula for distance, it'll be the absolute value of ax plus by plus cz plus d divided by the square root of a squared plus b squared plus c squared. So again, just thinking about how that just extended, right? Obviously in the denominator, it maybe is more obvious because you had one more term, but in the numerator, your c still is one of your coefficients that has a variable z with it, and then it says plus d. So yeah, we'll just work through this, and then again, not that it's hard, but just sometimes it is nice to see an example worked out, or certainly you could solve it on your own, pause the video, and see if you get it, or see if I get it. All right, so distance equals, let's see, so ax, so a is 2 in this case, x is negative 1, plus by, so b is 1, and our y value is 4, plus cz, so our c is 3, our z is 2, plus d, which is negative 5, all divided by the square root of a squared, so 2 squared, which is 4, plus b squared, which is 1, plus c squared, which is 9. So let's take a look at that numerator. We get the absolute value of negative 2 plus 4 plus 6 minus 5 over the square root of 14. So what is that? Negative 2 plus 4 is 2. 2 plus 6 is 8. 8 minus 5 is 3. So either 3 divided by root 14 or rationalize 3 root 14 over 14. So, and again, because this topic starts dealing with lines and planes, it's just nice to review how to find distance. And so, that's why I wanted to start this unit with this particular topic.